My name is Klaas Nienhuis. I work at DPI Animation House in Scheveningen. About the main guy, we are the people who developed the 3D modeling part on the first few releases of UR, the architecture layer from the NAI, the Dutch Architectural Institute. We didn't develop the application, that was done by Triangle Studios, who were in team communication, worked on the application as well, but we were responsible for all the 3D stuff. I'd like to first show you a little movie we did for the first release of Rotterdam. So what you see here is us explaining in a tiny movie how this stuff actually works, why this is a good thing, and we show that you can see your city. In the beginning your city was Rotterdam, of course, in a whole different way. The Architecture Institute is not showing you buildings which are there, obviously, because they are there already. But they show you buildings which are not there yet, or are not there anymore, or will never be there because they were just an alternative designed by an architect which was never executed. Beside that, we show that there are audio tours inside of UR. Audio tours were actually the beginning, the inspiration for this application. The Architecture Institute first thought, well, let's make an audio tour, and then it developed into an application like this. And of course, within UR, we didn't put the entire model of Rotterdam, but for the sake of the explanation, we put the model in the animation. And for people who know Rotterdam, this here is an alternative design of the Euromast, which is a quite funny idea, because everybody knows the Euromast is a kind of shape with one column and a flying saucer in it. But it could have been totally different if some architect had better connections. Well, modeling for UR or modeling for Layar, there are many different ways to do it, and we have done quite some modeling for the platform, but we've also instructed many people to do modeling for UR, because in the beginning the modeling load was quite high. Much hands needed on the mice, and well, we couldn't do it alone. And some architectural offices, they already had models, and they say, well, we can do it ourselves. And then we said, okay, we need to spread the knowledge, do some of it ourselves, but well, help people make the models. So first we had to figure out how to do it. There is some information on your website or the website of Layar. So we first tried that. And it didn't work out very well. The specifications, let's get right into the details, which we found on the site of Layar, were each model can have 5,000 triangles and the texture of 1024 pixels. Well, you can skip through this. This is my company. Right, this is what many architects expect. Let's put our building into the mobile phone. Well, this doesn't work, and if you skip to the next one, because they would like to have this inside of your mobile phone. Well, this is not happening yet. We just have it's just an iPhone. You can skip maybe it's an iPhone or Android. This is the type of model featured in UR. It's not very sophisticated. It's not very high-end in well, visually, but it is recognizable. You can see the shape of the building. You can recognize, if you actually know that this building has been bombed in Rotterdam and it was a hospital and it was in the inner city. Probably nobody knows that anymore. If you skip, well, I'm going a bit like this, but we had to explain to all the other people modeling for us and to ourselves and find out how does this process work. We use 3D Studio Max, so that's where we start. A lot of people use SketchUp, so that's even before that. And probably, as you know, you have to convert this stuff to L3D format through your converter. Well, first go through the OBJ format and then put the object in the CMS made by, I think it was in Team Communication, and then it gets in UR. And this already is, although it's a linear process, is quite difficult to grasp for, let's say, an architect. Again, they say, well, you have the model, just put it in and it will be okay. Well, it won't be okay. If you skip to the next slide, please. Because this is the stuff architects give us. Skip. Or this is stuff which comes from the archive of the Architecture Institute. Beautiful drawings. I'm an architect myself, so I'm delighted to look at these drawings for the new rowing club in Amsterdam. Beautiful. And if you skip the plans, you can skip on more drawings. So this stuff has to be made in 3D as well. If you skip, or buildings like this, where actually this drawing is prettier than most texture baked GI stuff. Why not draw it by hand? Or well, this is one of the results. This is the old bus station by Koolhaas. And if you skip, well, this is not so relevant. I should have left more slides out. Skip. This actually, the positioning of the models in the beginning was quite a hassle, because we had to position our models through geo coordinates, which is fine, of course, because that's quite exact. But there was no way to preview if the model was okay. So this was actually one of the big hurdles we had to take, how to put some building exactly in the right spot and being sure that it's there without having to visit and looking through your mobile phone, and to make sure that it's on the right spot. Where you know that the GPS signal might be a little bit off, and if there's a tram coming by, that your compass just goes with the tram. And so in the beginning we had to put our markers on the corners of buildings, because we know where the corner of a building is. It's probably on the corner of some street, and we can put the corner of the street very easily on the map. But that wasn't very beautiful, because then your marker would be on the corner of the building. Usually you would expect some building or item in Layar or in UR with the marker in the center of the building or the entrance. So you go to the middle of the building and you see it all around, and now the building is there, but your marker is there, so you're actually trying to look there to get the information, like the texts, the other images. Well, it was a big hassle. Luckily Ronald helped us out with a big update and with the OpenStreetView preview in the exporter.
Thanks for the feature request.
Yeah. Yes, let's go on. Okay, so to the modeling, because that's our specialty. So these are the specifications on the site of Layar: 5,000 faces, triangles. I expect a texture of 1024, and you can unwrap that if you like to bake beautiful lighting into it. Well, this works fine for a single building, and actually Layar has been previewed to clients with the Markthal in Rotterdam by NVRDV. Beautiful building, it was fully modeled and it looked great. It was pretty heavy, but okay, it was one building. But if you skip, well, this is from your side, you can go on. This is an example from Utrecht. The station, Vredenburg. In the release of Utrecht, for instance, actually in all cities, there are many buildings close to each other. Because you go to the center of the city, and as a user, you want to see at least a few buildings in 3D. And this is a big problem. There are already 7 buildings here, 1, 2, 3, 4, 5, and this long street thing is divided in 2, the cross-section 6 and the canal 7. This is way too heavy for your mobile phone. 7 times 5,000 faces, 7 times this texture. It doesn't work. It will crash your phone, it will heat up. Especially in Rotterdam, in that release there was no iPhone 4 yet, so it was all iPhone 3. So we had to decrease the standards. We were quite shocked by this. And if you skip, so these are the specifications Triangle Studios and Layar, and we kind of set up. We didn't like it, but that's the way it goes. 2,000 faces, triangles, and a texture of 256 by square pixels. So this means we somehow have to push every building within this small container. And it's doable. These are a few buildings in Amsterdam. You can skip through them. They look pretty good, even textured if you skip. This looks fine, of course. This is nicely rendered. You won't see this on your telephone, but still the textures are not that blurry. The texture is not everywhere the same. It's okay. So how do we communicate this to participants, architects, other 3D bureaus? Because we kind of thought up a modeling process, a modeling system, how to make these models. For instance, this was a beautiful model, if you can see, but it says here 2035 triangles. Excellent. And if you skip to the next slide, they gave us these textures. They said, okay, a texture can be 256 pixels. So every texture here is 256 pixels in square, which is of course way too heavy. This doesn't work. But they have baked lighting in here. So they made a projection mapping type of building. We had to decline this model. They said, okay, fine, we put it in our own layer, and they did, and it looked great, of course, because texture baked and all the lighting in there, but it's a layer with one building. So, specifically for our client, and it works. It's very nice. The building looks great. Okay. This is another one. If you skip, the model looks okay, but they have some kind of projection mapping of facades. Very large TIFF images. If you skip to the next image, just for a test, I scaled down these images to fit within the boundaries, and well, nothing's left. It's just a big blur. So this doesn't work as well. So, how do we model these things? This is the hospital I spoke about. And I'd like to demonstrate our method with this drawing, because it's a very good drawing to demonstrate it by. The type of modeling we use, I call it tile mapping. Probably there's another term for it. It is not unwrapping, it is not projection mapping, it's tile mapping. And the thing we do is we isolate repeating patterns from the facades, because facades is all we model, and we put one such a piece, such as a window, a double window like this, in a separate texture file. And we put this window, a single window, in a separate texture file. And let's see what's repeating more. Here I've got these three windows next to each other. Let's put that one in a separate texture file as well. Such a square window, a roof edge detail. So you look at the building, what's repeating, put that in a separate texture file, and make a box like a boxy model. If you skip to the next slide. So we slice up the texture space we have in any amount of smaller textures. And I know that this is not optimal for any video card, actually, as well as the stuff UR uses, or Layar uses. But it's the next best thing for us, because it makes it possible for us to tile or to repeat pieces of a facade. Why is this good? I can make a very sharp texture, for instance of 64 pixels, and repeat that all over my building. So I can recycle my pixels and make the building look very sharp, not blurry, but still have a very limited amount of texture space used. So this is kind of the next best thing in terms of video driver stuff. So here's some of the textures we used in this hospital. Actually, we've made a high-res model for this and rendered those things, but in the end, you just end up with a flat texture. If you skip to the next slide, and we put that on a very boxy model. This model is actually quite light, and if you think about the process, usually when we are modeling, we do a lot of architectural visualizations. You first make the model and then you start to think about your materials. When modeling with this system, you have to do both simultaneously. You have to look at the building and kind of classify it. Is this a more geometry type of building, or is this more a texture type of building? And develop both items at the same time. So when I look at the drawing, I start counting how many different types of textures do I have. Let's count: 1, 2, 3, 4, 5, 6. Large one here for the entrance. 6, just one for the color. Maybe one for the edges. 7, maybe 8 textures. So I know I've got 8 textures. I know I have to stay within this boundary. I know I have to make these textures power of 2, so 2, 4, 16, 32, etc. So I kind of predict how large my textures are going to be. If I'm getting into trouble with my textures, let's say I've got some type of building, postmodern architecture, large building, with a classicist facade here, and neo-Gothic 2011 style there, and some modernist stuff there. If I've got a lot of different types of facade, I'm bound to have too many textures than I can handle. So then I have to decide, okay, let's do less textures but model more. That's the type of decisions you can make at the same time. So these are just for demonstrations. This is 64 by 64 pixels, and they look pretty sharp if you go to Rotterdam and have a look. Okay. Well, we thought this was all very clear once we thought of this. So we've sent this out to other people modeling in 3D Studio Max, other people modeling in SketchUp because they are cheaper, and we were confronted with all kinds of problems, of which we learned a lot. And these are the problems I'm going to use to demonstrate how to model stuff and how to not model your stuff, and what we have learned about what Layar can do in terms of an engine. So these are, well, not very random, but kind of random mistakes made by us, by other people, where I'm going to demonstrate what's happening. If you can go one back, please. So, Layar can handle intersecting volumes pretty well. There are other engines which have a lot of problems with the Z buffering, which phase is in front of what. But Layar, in my experience, doesn't really have a lot of problems with this. So this means you don't have to model very cleanly. You can just intersect two boxes with each other. This makes for a very nice, interesting shape, and you don't have to care about what's inside the volumes. So to illustrate this, this is a facade. It's actually the Bijenkorf in Den Haag. And there are some kind of ribs or details which are repeating. Here's the next one, here's the next one. And the guy in SketchUp, they model very cleanly. They cut out every face. If it's not visible, beautiful. But in the end, it will give you a lot of faces. Because the shape you see here, the shaded shape here, that's what you're seeing. The hole here is just inside of the building. Nobody sees that. So why not model a box? It has 6 sides, which is 12 triangles. And it's less than the triangles I'm counting here. So intersecting volumes, a good thing, works. Let's move on to the next one. Well, this is kind of obvious, but you have to use appropriate segmentation when you have rounded shapes. This is also the Bijenkorf. This is near the entrance. So you're bound to get close as a Layar user to this volume, but this is really too much. And if the round volume is some kind of spire on top of a tower of 100 meters high, you can just do with 3 sides, because you're always going to be at least 100 meters away from this piece of geometry. So the further the distance, the less segmentation. Basics. This is also a nice one. Windows. Buildings are bound to have windows, a lot of them. And well, my English is not really up to par here, but windows have neggen. The neggen, that's the depth, the distance between the layer of the facade and the layer of the glass. So if your window is very deep with inside of the building, your neggen is large. And if the glass is just in the same plane as the bricks, for instance, you have 0 neggen. Well, neggen is something which gives your building a lot of volume, a lot of plasticity, and it's good to make it, but it also takes up a lot of faces, especially if you've got a lot of windows. And if you don't have the budget anymore, you can take an escape. You can just put the windows in front of the facade. That's not what they did here. If you skip to the next slide. They still cut holes in the faces of the facade, but you really don't have to. Why not put a small plane like 5 or 2 centimeters in front of the facade? Nobody sees it. It's just a small distance, and you will get away with it. And then you don't have to cut all these holes and spend all that geometry on well, emptiness here. So if you don't have the budget anymore, or if you don't have a neggen anyway, just put your windows in front of the facade. Easy. And I'm actually not sure if there's a problem with Z fighting here, so I usually say, well, 5 centimeters. You're never going to go that close to a building, because your GPS lock will switch it somewhere else anyway. Right. Other tricks. This is a pretty large building, and it has a lot of windows, and every window is 2 triangles here, and there are a lot of them. And if you skip to the next slide, here's a trick to minimize the amount of geometry you spend on large planes of many of the same windows. So here are all the windows isolated. They're not touching, so that's a problem, because if they were touching, I could just tile tile the texture and it would just repeat itself over and over again. That doesn't work here. What I could do, I could, if you look at the texture here, let's say this is the texture of the window itself. I could make the texture a little bit bigger. So spend some pixels here. Put nothing in here, but make the texture bigger anyway. So if this is a PNG, you use transparency here. And this empty space here could be the same as the empty space around this window. So I kind of make my spacing in the texture. Then I could replace all my separate windows by one big plane and tile my windows onto there. Still have the transparency. And this works. So this is a neat trick to get rid of a lot of geometry. And you could spend this geometry, which is repeating anyway, on a nice entrance, for instance. Developers, this is a new building, so there's probably a developer, they always want to see a nice entrance where they put, well, relatively a lot of money in, so it's good to invest in that geometry-wise as well. Okay, well, bad habits anyway are, I don't know if there's another term for this, but I call it redundant triangulation. So you model a rectangle, but actually the rectangle is made up of 6 triangles. Why? Don't do that, or skip to the next slide. Model some kind of balustrade, railing elaborately. Why model these sides? It's going to be far away and it's small. And why model the back side? It's not necessary. Or the bottom side. You can just get rid of that. Anything on the zero plane. If you're doing overground objects, you can get rid of, because you're never going to go underneath the building. You could say the same for roofs, because when you're on eye level, you're never going to see the roof. But there is, as you know, a bird's eye view feature. That's why you need to keep the roof. That's very important. Okay. For instance, a model like this. This model actually is pretty okay, but there's a problem. It's about a quarter too heavy, and what people forget is that you can gain a lot of or improve your model a lot by focusing on the small items if you have a lot of them. For instance, there are these roof windows. There are a lot of them. They're very small, but they are bound to have a lot of geometry. And it doesn't matter if a triangle is big or small. One triangle is one triangle. So if you can decrease your small triangles, that's a good thing. So this is the thing in SketchUp. It looks very clean, very nice. I'm going to get back to that because SketchUp is not as clean as it looks. In reality, this is really a mess. Like, it's probably difficult to see from a distance, but this is a rectangle, but it's again built up of 5 triangles. There are 2 boxes on top of here. Well, if you've seen the model rotated, there's all kinds of stuff inside. It's horrible. And just by making one of these very efficient and repeating it, you can just cut the model in half, triangle-wise. This is also a nice example of how to creatively juggle with your model. This is a building which actually has been built at the moment near Blaak Station in Rotterdam. It was not finished at the time, so that's why it's EUR. If you skip to the next. It is a building with an interesting facade. It has a kind of a tree-like appearance. The penante, the spaces in between the windows are wider, narrower, or a little bit unstraight. And this makes it difficult to locate repeating patterns, because it's kind of random or tree-shaped. So how to make a sharp texture, make a sharp model, and still make it fit within the boundaries. So what we did is we scrapped all the tree-like appearance and just took one standard window, repeated over the volume. Well, the volume is very simple. It's just one box, another box on top, and a third box on top of that. So that's easy. But now we need to get the tree-like appearance back. And our first instinct was, well, let's do it in textures. But it's easier to do it in modeling. We just invest about 90% of the model into the tree-like appearance. Again, put it a little bit in front of the facade, like 5 centimeters. And if you go to the next slide, you can see that it has a tree-like appearance. And the next slide shows you the textures we have. We have a standard window. This is the entrance. And there are 2 colors of the tree-like stuff in front. So that's why you have to develop your textures and your model simultaneously. Because if you say, well, let's make the model first, and let's worry about the textures later, or let's give the texturing job to our texturing department, well, it's bound to fail. You have to do it at the same time. Okay, you can use opacity maps, which is very nice. This is probably some museum here in Amsterdam. Yeah, that's that actually.
Well, yes.
This is a textury building. There's a lot of small details. There's rollagen, like special layers of brick on top of windows. There's stuff around entrances. There's all kind of decorations, and there are these roof windows again, with the nice, well, bell-shaped features here and some feature there. So for this kind of stuff, we use opacity maps. You draw a rectangle here, just make it one face, 2 triangles, draw an opacity map with an appropriate amount of pixels, and put it on. Yes, please. Again, this model was built very nicely with all the stuff which is intersecting cut out, booleans or whatever, which is very heavy. And since Layar can deal with intersecting volumes, you can see, for instance, a shape like this. This piece is a facade with a roof, a hip roof coming down, and it's nicely cut out of this piece of geometry. Well, you can draw this one just as easily in 2 rectangles and get rid of all the redundant stuff. So you're never going to see these. This is kind of obvious, but still, this happens a lot. If you don't check your model thoroughly, delete everything which is inside something else completely. Well, this is more of the same. So what we actually did, or what I did, I checked these models inside 3D Studio and just made these PDFs with all the remarks and send it back to the people who made it to make sure they understood, and the models improve. So if people make more models, it really improves. Well, this model is too efficient. This is 1,000 triangles, and at a certain point we were focusing so much on, well, let's make it light, let's make it fit within the container, we said, that people were kind of scared and let's not go over this limit. But of course it's not the goal to stay within the limits, it's the goal to make a building which is as nice as possible within this limit. So if you do something like this, creep up to the face count and the pixel count as close as you can. So I've advised, well, this is an entrance, model some stuff here. The doors are deeper, there's a large nege here, nice windows. Oh yeah, this is nice. This is, I should come back to this, SketchUp. If anybody has questions, by the way. Otherwise I'll go on. The models from SketchUp. SketchUppers, there are many SketchUppers around. You all know Google Warehouse. Lots of people can reach there, and they are all very happy to model for money just about anything, like a church. But there are a few problems with SketchUp. Of course, it's a great package to model. It's easy to learn. It goes very quick, but it takes some of the control from you. For instance, you cannot get a reliable triangle count from SketchUp. It will just not tell you the exact amount of triangles you're using. It can be off like 10%, but it can also be off 100%. You never know. Another thing, if everybody who has worked with SketchUp here, it's this nice kind of push-pull modeling. You draw a box, and then you draw a rectangle, and you pull that rectangle out, and then you've extruded something. It's all very intuitively, but it does all kinds of stuff for you, like segment all your faces, cut stuff up, and it doesn't show you, because it doesn't really matter in SketchUp. But if you skip to the next slide, this is what happens if you start push-pulling. For instance, there's a roof here. This model comes from SketchUp. There's a roof here, which is just a hip roof, right? Hip. Where one side could just be one plane, a rectangular plane. But because of the type of modeling and the push-pulling, you've got all this triangulation here. I call this redundant triangulation. And this happens all over. For instance, it is not very obvious, but the shape of this facade here, it's like you're going up, here, 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 and straight down. If you go straight down from this corner, why is there an extra vertex here? It doesn't really seem like a big deal, but if you've got this going on all over your model, you're getting into big problems. Well, it's all over. It's really horrible. And again here. Okay. And again. I just want to make sure that you get this. Okay. You can skip this one. Well, I think this again was the light model where I said you can put more detail in. Okay, let's go to Utrecht. Other models, like I said, it is a good thing to be able to put faces on top of each other and not noticing it, like with the windows. You can do the same with streets. If you have a brick-like street and a concrete-like street, you can just put them on top of each other, and you don't have to slice it all out, which costs you, again, faces. Make sure you use enough distance. Aesthetically, it's always good to give your model a clean ending. For buildings, this is pretty easy, because a building is usually an entity with a whole lot of nothing around it, but for streets, new streets, this is pretty difficult. Where do you end it? Well, you don't end it like this, where there are some bricks and then there's the curb, the stoeprand, the curb edge sticking out, and another piece of street here. You just make a nice ending, make it anywhere, but make it clean, cut it clean. Okay, this is an example of unwrapping, a bad example. This is why we said don't do this. If you go to the next slide, this is actually the texture. To my surprise, it worked pretty good. It was a texture of 256 pixels square, but this one here is the roof, and it's far too small for the big surface that it has to cover. You don't see the roof that often, but still, it should be nice. It deserves it. And it's an important roof scale for this type of building. If you look at the drawings from the architect, there are little garden houses on top of the roof. It's green. It's by Marlies Romer, and well, if she put the energy to design it, you should put the energy in to model it and texture it properly. Well, okay, these are some examples of buildings made in Den Bosch. Den Bosch was entirely modeled by enthusiasts. The Bosch Architecture Institute, they recruited some enthusiasts who had some experience with SketchUp, and in the end, you can flip through these. They made quite a lot nice models. This one was quite difficult. Actually, it was hardly doable, but still, this is within the boundaries. It's actually very small. It's like man high. Maybe skip a few more. I think I'm rounding off in a few moments. Right. One more disadvantage of SketchUp is that it uses double-sided faces. It's very nice if you stay within SketchUp, but outside of SketchUp you will have great problems. For instance, within Layar, faces have one side. The other side is transparent. The same goes for 3D Studio Max, usually if you set it up like that. So if you forget about this and just import a model from SketchUp, which looked great, you can get this, a model full of holes. So if you can set up some kind of special display in SketchUp where you can see which face is facing you and which one is facing away. So the blue stuff is facing away here. I was relieved that this feature was inside of SketchUp, so they could fix it instead of me. So this is something to keep in mind. If you are happily modeling in SketchUp, check the face orientation in the end, because you're bound to have problems within the layer. Right, this is the face style. Yeah, this is a good example of the Bijenkorf. Actually, this is the one I showed you in the beginning, with the boxes sticking through. I think I'm almost getting there. I have a request as well. We run into problems. Maybe if you skip through to the map of Utrecht. More. Oh yeah, right. One problem we encountered in Utrecht, where a few buildings were really connected to each other. For instance, the new train station is here. If you skip to the next slide, there's a large group of stairs which is coming up to the train station. If you skip to the next slide, there's the new Stadskantoor City Hall or something, which is actually poking with its columns inside of the train station. These models, they have to fit exactly next to each other. Well, this is of course doable, because if you place them right in the converter, they will, as a group, they might shift due to the GPS problems or your compass, but they won't shift separately from each other. So, okay, that's fine. But it is very difficult to find the right coordinate of this building, the train station, and in another map finding finding another right coordinate for this building, and finding another coordinate for the array of stairs. So my request to Layar would be, there it goes. At the moment you have the same location for your marker and your building. The 3D model has the same location as the marker you see in your AR view. It would be very convenient if these could be separate. So that means I could place the marker for the station, like in the center here, and I could place the marker for the Stadskantoor in the center, and the marker for the for the stairs in the center. But I could set these models up in 3D Studio Max to have the same zero location. Maybe the next slide? No, a few slides back. Back one more. Like this. So there's one coordinate system for all three buildings. So the 3D models use one geolocation, but their markers needn't be on that same location. This gave us a big headache. The client was very disappointed that we couldn't make it work. We thought that this would work, but it didn't. So for next release, this would be very good, I think. Okay, what's next? Last thing, underground objects. There are plans for an underground layer here in Amsterdam. And one of the challenges for underground objects, of course, it's very nice to go into UR, look at the buildings, and then point your phone downwards, and hey, there's the subway station. You're waiting so long for it to get there. And why not just have it there underneath your feet? You can actually just stand on top of it and look right down. So one of the challenges we're dealing with now is how do you show underground structures? Because it's very nice to see a set of stairs here and a platform, but it doesn't really give the hugeness, the impact of a subway station. For that you need the facade, if you go one slide back. This is huge and nice, but you don't really recognize it as a subway station, so you kind of need both of them. So how do you do that? I think I've come to an end of this presentation. Let me just check, make my request. Yeah. Are there any questions? Yes, please.
What do you do with very weird buildings with a lot of round corners and deep windows and lots of details, which is hard to model?
Well, we model it anyway, that's for sure. If you go, if you remember the train station, for instance, the Utrecht train station, it had this large wavy, here it is. It has a large wavy roof, which looked kind of impossible to make, but in the end you only need so much segmentations. There are moments, though, that we also have to recognize that a building is just too heavy or too big or too differentiated to model. For instance, we did the Oosterdok Eiland here. And if you know it, it's an array of like 6 or 7 really different buildings, and it was offered to us as a set of one building, and we couldn't do it. We had to slice it up into 7 buildings. So if there's a way for you to see a clear cut, if you can separate one piece of the building from another piece and make it logical, then that's your way out. Your way out of jail. If that's not an option, you have to get rid of details. That's the only option. We do it all the time. We say, well, okay, that's a nice window. It's on the back side, and we have something on the front which is similar, which I'm making anyway, so I'll just put that there.
And is the client satisfied with that?
Yes. Yeah. Well,
you should explain it well.
I mean, you have to manage their expectations, right? And you have to tell them it's the screen is this big, and they have to know that they're not going like this close to the facade, but they always want to see the entire building. So you can preview your buildings in such an iPhone template image and make them see, okay, well, the window is not that important. If they insist anyway, well, then you can say it won't work with your KPN network because the model will just be too heavy. Usually our models are less than 200 kilobytes, much less than 200 kilobytes. And if you have to load up 7 or 8 of these models at the same time, along with the interface and all the images, you need to have small models for that. So then you get it more like talking the detail out instead of modeling.
In modeling buildings which use tileable textures, do you use multiple UV channels and linear mapping to do the same effect?
Yeah, at the beginning I like to keep I really like to keep everything within one mesh and use multi-sub materials. In 3D Studio that is. But why do it? It's too elaborate. Just separate all the facades from each other, planar map them, and tile your textures on top of that. It's really not necessary to make it more complicated. Anyone else? We have to move on.
And are you going to be around for a bit? People come up with more questions.
Yeah, sure.
Like
yep.
Well, thank you very, very much.